Alright, so now that I have my player and my floor, the next step is going to be to add movement. Um, Even though we can get gravity for free, more or less, by just adding a rigid body, there's no free way to just add movement for a side-scrolling character in our game. So we're going to have to add that functionality ourselves. And the way to do that is by adding a script. So a script is a new category of asset. So we're going to create a new folder in our project's assets directory, and we're going to call this scripts. Inside of the new scripts folder, I'm going to right click, I'm going to choose create, and then select C# script. Now it's important when you're creating scripts to name them properly right off the bat, because it's not super straightforward to rename them later. So this particular script is going to describe the behavior of our player character. So I'm just going to call it, I'll call it player character. And then I will double click it to open it in our script editor. Alright, so here's Visual Studio. This is the default script editor for Unity, and our task here is to add movement to our player. Alright, so adding movement is kind of a two-step thing here, because we want the player to move based on the player's input. So the first step is going to be to read the input that the player is providing via the keyboard or the gamepad or what have you. And then the second step will be to use that input as data to influence which direction and how fast the player moves. So the first step there, reading the input, we're going to use a function called getAxis. So I'm going to just Google input getAxis, and we can see that the Unity scripting reference documentation comes up, and this will give you more information about the specifics of how this works. But you can see that this function returns a value between -1 and 1 based on the input that the player is providing of a virtual axis. So if I were to go into update here and start typing input.getAxis, you'll see the IntelliSense tooltip here. It says that we need to provide a string axis name. So the way to find that is to go back into Unity and go to Edit, Project Settings, Input, and that will open the Input Manager. And in the Input Manager, you can expand this heading of axes here, and you'll see this list of axes that are built into Unity when you start a new project. You could change the size to a larger number and add new ones, but because so many games use similar controls, there are built-in axes that are pretty useful. So for our purposes, this horizontal axis is more or less what we need to get our horizontal input in our game. So you can see this is set up to have the left arrow key as a negative button binding. So when the player is pressing the left arrow key, it will return, our getAxis function will return a -1. And we have the right arrow key bound for the positive button. So when the player presses that, our getAxis function will return a +1. And then we have the alternate buttons of A and D so that we have WASD input support sort of built in here also. And you can also see there's an additional horizontal axis definition here that's set up to look at the joystick. So because we have both of these, when we go back into Visual Studio and type in that name horizontal inside of the quotation marks to get a string, that will work for reading the input on the x-axis, which is our horizontal axis, from both gamepad input as well as keyboard input. So that's pretty useful. If we go back and look at the documentation, you can see it's returning a float. So, and that float again, it's our -1 to 1 number based on whatever the player is pressing. So we need to store the result of calling this function somewhere. Not, just calling it won't really do anything. It'll just tell us a number, but we have to then use that number somewhere else. So in order to store this, I need to create a variable up at the top of our class so that it has class-wide scope and we can use it all throughout the whole class, not just inside of this update function. So the type of the variable is going to be a float, so we'll say private float horizontal input, and then in update we'll say horizontal input equals input.getAxis horizontal. So now every frame we're going to store the latest input on the horizontal axis in this horizontal input variable that we created. Now our second step here is going to be to use this number to move the player around. So there's a lot of different ways we can move the player around, but because we are setting up our character controller to use the built-in Unity physics system, I want to use a function called add force to move our player. And this way our player can interact with the various other elements of the built-in physics simulation in a way that doesn't override any settings, and everything will just sort of work together in a nice way. So on a new line underneath where we're getting our input, I'm going to make a new function that will make a call to rigidbody2d.addForce. So we can look that up. And you can see that this function belongs to the class rigidbody2d. So we actually need to have a reference to the rigid body that is attached to our player's game object in order to use this one. Input is a static function. So input.getAxis, this is a static function, so we don't need a reference to any particular instance of input. But rigidbody2d is just a regular class, so we have to find a specific instance of the rigidbody2d that we want to add a force to. And in this case, that's going to be the rigid body that's attached to our player. So we need to figure out how to get a reference to the rigid body that's actually a component on our player character here. And there's a handful of ways to do that, but one way that's kind of intuitive is to create a variable that's exposed to the editor and then drag the actual component that we want into that property that we exposed to the editor, and that will initialize it for us. So um, the way that I like to expose variables to the editor is with the Serialize Field tag. So I'm going to create a new private variable here. It will say private rigid body 2D, because the type of this variable is going to be rigid body 2D. That's what we need. And I'm going to name it RB2D. I would normally name it rigid body 2D just with a lowercase r, but unfortunately there's a built-in variable named rigid body 2D that we aren't able to use because it's a deprecated reference to some old way that Unity used to have this set up. So unfortunately they stole the best name and we can't use it. So instead we'll use this kind of awful abbreviation. Alright, and so in order to expose this to the editor so that we can see it inside of the Unity editor, we need to use the Serialize Field tag. So it's just you use the brackets and then type Serialize Field. And what that will do is expose the very next private field to the Unity editor. And that way we can just leave this RB2D variable private and still expose it to the editor. We could also expose it to the editor by making it public, but we don't need this variable to be public. Nothing outside of our player character class actually needs to be able to access this variable. So it's a better practice to just leave it private and expose it to the editor with Serialize Field. So if I save this, you can see we have a little asterisk up here. That means we have an unsaved change. So I'm going to save the script with Control S or File Save here, and then go back to Unity, and our script will compile. And then what we need to do is actually add the script to the player character game object. It's important to remember that unless you actually add a script to a game object in the scene that you're running, the script will never ever get executed. So I'm going to drag the player character script onto my player character game object. You could also drag it onto the game object in the scene, or you could add it by going into Add Component and searching for its name. And just be careful that you don't add more than one of the script. If you happen to add an extra one, like that, you can click on the little gear icon over here and remove the extra one. And you'll see we have this RB2D variable that's been exposed to the editor. And we're able to plug in whatever rigid body 2D we want into this slot that we've created. So the rigid body 2D that we want to be able to manipulate in our player character script is the one that's actually attached to this game object. So all I need to do is just drag this into the rigid body 2D slot that I created. Now if I go back to Visual Studio, I can start to call functions on this RB2D, and it'll actually have a valid reference to an actual rigid body 2D that I care about. So what I'll do is type in RB2D here in update, and then period, and I want to use add force, and then open parentheses. And you can see there's a couple of versions of the add force method. We can do the first one, which just takes a vector2, which would describe the amount of force we want to add, and the second one is a vector2 along with a description of the force mode. Let's just start with the first version here. So we need to tell Unity how much force do we want to add. Well, we don't really know, but we do know that it's based on this horizontal input. So what we can do is we can say new, well, actually let's add a force based on vector2 dot right times horizontal input. And so what this will do, vector2 dot right will just give us a vector that is 1 in the x and 0 on the y, which will make sure that we're not moving our character at all on the y-axis, and we'll multiply that times our input so that if the input is negative, we'll be moving to the left. If the input is positive, we'll be moving to the right. And that's how we want our game to work. There are a few considerations, though. We need to actually, so we don't know how fast we want our character to move yet, right? Like, it's unclear how fast this would actually move. So it's a good idea to add a variable for that. We could come up with some arbitrary number like 5 or 10, but we have no clue if that's going to be the right amount. And the only way to really find out is to play test the game. So rather than hard code some sort of number here, we're going to create a variable and expose it to the editor so that the designers on the project can tweak it and adjust it until they find what feels good. So we will make a new serialize field. It will be a private float, and we can call it speed. And we should go ahead and initialize it with some value, just so that it's not 0, because if our speed is 0, the character won't move. So we can say that something like 5 is a reasonable first guess at how fast the character should move. So we're going to add our force. It's going to be vector2 dot right times horizontal input times speed. Now, another consideration that we need to make is that because update is called once per frame, and our game's frame rate is really, really fast, we don't want to make this physics call that rapidly, because physics calls can be expensive, and that can affect performance. So in order to keep our game running smoothly, we should actually only make physics calls inside of fixed update. So whereas update is just getting called as fast as the computer can possibly handle it, fixed update is called at a fixed interval. And it's still going to be fast enough that our movement will feel fluid, but it's also going to be slower than update, which will allow us to keep performance better than if we were to make physics calls as fast as we could in update. So we'll just take this line from line 25 here, and we will use Control X to cut it out of update, and instead we will put it in fixed update. So it's just a general good practice to make physics calls in fixed update. But we want to leave our input reading in update because we want the game to feel responsive, so we should be updating the input as fast as we can. And this is comparatively inexpensive on the computer, so it's okay to leave it in update. Alright, so if I were to save the game now and go to Unity and then run the game, you'll see that if I use the A button or the D button or the left arrow key and the right arrow key, I can actually move my character. Now it doesn't really move the way I would want a character in a side-scrolling game and a typical side-scrolling game to work. It's like really, it's the acceleration is very slow, and then actually if I just were to hold it long enough, it'll just keep going faster and faster and faster and faster without any kind of limit, and then it kind of slides and takes a while to slow down. So this isn't really how we expect characters in platforming games to move, but it is a good start. So in the next part of the video, we can start working on making this behave a little bit more fluidly and in a way that feels more responsive and just good and what we're used to as players.